Okay. So Dylan and I both play lacrosse, and we initially were going to do something about shooting a lacrosse ball, but due to just the physical limitations, because there's a cord, the accelerometer, we changed it to the more defense aspect, I guess. So we talked about gloves and stick checks and what glove would be the best to protect your hands, or what kind of glove. And we tested 3 gloves, and they're gloves that are common, that are big on the market right now. And we also tested a sleeping bag for no other reason than just to do it. Alright, our goal was to find the coefficient of restitution of 3 different gloves, and how much energy was taken away from the system when we hit, and I'll talk about our setup in a second. But we tested these 3 gloves. You don't really probably care about the names, but these are they're called K18, Cell 2, and Brine King 3. And a sleeping bag. These are our hypotheses. We thought that the best glove would be the one that takes the most energy out of the system, and the glove with the highest coefficient of restitution would be doing the most negative work. We built our experiment because we didn't want to use the lacrosse stick. We had to have some way where we could keep the velocity somewhat constant, and so we built a wooden setup with pieces of wood, and this is our equipment. We used a 25G accelerometer and a force plate. We assembled it, we lubed it up, we put the glove on the plate, and we zeroed the force plate. And then, for the most part, it could stand pretty much vertical, so there wasn't really much of an initial velocity. And we did video analysis on our data. And this is what it looked like. There's our equipment. There's Dylan, where I'm in my basement, part of my basement. And then I'll show you a video. It's really short. I don't know how Dylan sets this stuff up. So we put points on the stick, and like Emily was saying, we were just kind of lucky because when we were analyzing, we had duct tape on there, so it was we could kind of keep track of the stick, but it did get blurry at some point. So that was definitely a part of the error. And then the data. This was our data table, and we took the force, and then we also found the pressure. We found the approximate area that it would hit. We also found the time of impact by looking at from when it hit to when it bounced back up, and then we found the impulse. By plotting the points, we found the height and velocity, or the velocity was the result of taking the integral of an acceleration graph we had. And then using, just like the bouncing balls lab, we found the coefficient of restitution using 2 different methods. And our data was kind of crazy if you look at it. We had 0.5 to 0.9 and then 0.3 to 0.1 over here. So not exactly sure which way was best, and if we were to do it again, I would probably try to call the manufacturer and just see what the accepted values were or whatever. These are our sample calculations just to show you how we found them. By plotting the points, we were able to find this graph, and these are the graphs from the force plate, accelerometer, and then the integral of that acceleration versus time graph. There was a lot of error because when the board hit, it would wobble, and so the acceleration graph was kind of messed up. Also, just the scaling of how we did it. The video was a little bit shaky, Also plotting the points and the angle at which the board hit the glove also would make a difference in how much of how hard the board was coming down the glove. We concluded that the newest glove, which was Dylan's Cell 2 glove, offered the most protection. It was probably the firmest. It yielded the most negative work, so we came to the conclusion that since it took the most work out of the system, then it would protect your hands the most. And then I found this. This is courtesy of the Echo, and that is Dr. David Schuster, medical doctor. So. Thank you.
Do you have any questions for Craig?
How did you find that picture?
I googled Dr. David Schuster.
I suppose that's enough.